Okay, here's 27. Now, this optimization problem has a really simple context. There's other contexts that aren't as simple. And the challenge with those problems, I don't have one right in front of me right here, otherwise I'd do it, is creating the function that it wants. This one kind of explicitly tells you what the function is. If the sum of two numbers is if the sum of two numbers x and y is 12, what is the maximum of its product? And that gives us the function that we need. So the product, I'm going to write, to write this function, I'm going to write p of x. Actually, I don't know what the independent variable is. P equals x times y to the third. Oops, wrong one. X to the third y. All right, so I don't know what this is a function of. Is it a function? Is it going to be a function of x, or is it going to be a function of y? And what determines that is what I can substitute into it. So, and what would be easier? The other equation that it gives us is x plus y equals 12. It's kind of like a system of equations where you're always going to have to set up at least two equations. This one is really obvious which equations you can set up. And then you're going to take one of those equations, in this case my green one, and I'm going to solve for one of the variables so that I could plug it into one of these variables over here. And that will make that will tell us what our independent variable is going to be. And then we'll be able to take the derivative of it and optimize it, blah blah blah. So let's try this. What can we do first? Let's say we solve for y, and we went y equals 12 minus x. If we got that, then we would write our equation as our function that we're going to eventually take the derivative of as x to the third times 12 minus x. And this actually would be pretty nice because I just need to distribute this, so I don't have to use a product rule, and I can take the derivative of that. So it would be p. This one would be p of x, and so this would be 12x to the third minus x to the fourth. And so now we would just take the derivative of that. And what we're doing is, by taking the derivative, is we're looking for critical values that will give us a maximum or minimum. In this case, give us a maximum product. Okay, so what if now I just kind of want to pause on that one and say, what if we solved for x instead? What if we didn't do that, but instead we solved for x? So let's say we solved for x and we got x equals 12 minus y. Let's see what that one would look like. If I plug that, since it's solved for x, I'd plug it into x. I would have 12 minus y raised to the third power times y. Now p would be a function of y, because y would be the only variable inside there. This is probably why I wouldn't want to do this one, because I'd have to do the chain rule to take the derivative of this and the product rule at the same time. Or I can multiply out this like go 12 minus y times 12 minus y times 12 minus y for that 3, and then multiply by y. That sounds way more complicated than this one right here. As you can see, this is beautiful, ready for a derivative. Okay, so I'm not going to go this route, but it would work. It would work. All right, so let's find out what our x values would be. Y or p prime would equal, I picked p for product, would be 36x squared minus 4x to the third power, and I'm going to set this equal to 0 equals, I'm going to go ahead and factor at the same time, take out a 4x squared, so then I get 9 minus x. So I'm going to get two values of x here. I get x equals 0 from this factor, and from this factor right here I'm going to get 9. 9 right there. Yeah, that's right. Remember, you set those factors equal to 0. You go 4x squared equals 0, and 9 minus x equals 0. That's how I found those two answers. So which one is going to give us our minimum? Now to find out, I'm just going to plug them in. So I'm going to plug 0 in first, or plugging it back into the product function, which is this guy right here. I plug 0 into that, I get 0. If I plug 9 into it, that's definitely going to be a bigger number. We have 12, 9 raised to the third power minus 9 raised to the 4th power. Actually, yeah, I'm pretty sure it does. Here, this is what I'm thinking. This is 12 times 9 times 9 times 9. And this is going to be 9 times 9 4 times 9 times 9. So this number is going to be bigger. So I know it's going to be a positive number, which is important. See, I see the 3 9s, but then this one's only multiplying by 9, and this one's multiplying by 12. So this number is going to be bigger, which means we're going to have a positive number, which means it's going to be bigger than that one. So 9 gives us our biggest product. So the sum of the two numbers is this. What is the maximum product? Oh, we actually have to do this. Okay, so this is going to be our product. 9 is the x value that we get, so that's not our answer though, because it says what is the maximum product. Oh, boo. All right, so let me multiply this out. That's going to be 108 times 81. That's for this first part. Multiply that. That's going to be 8010. 0. That's going to be a 4. Then a 6. That's going to be 6. Then an 8. I add those up. I get 8, 4, 7, 8. And the other one is going to be 81 times 81. I'm sorry, I'm taking a lot of shortcuts. 9 times 9 is 81. 9 times 9 is 81. Now I multiply those two together. I get 1, 8, 8, and then 64. Add those together. I get 1, 16, 5, and then 6. Okay, so now I'm going to go 8, 7, 4, 8, and I'm going to subtract this since it says subtraction right there. And I get 7, borrow from this guy. I get 8, and that's going to be 1, and that's going to be 2. 2,187. Oh, thank goodness it's right there. Man, if it wasn't there, I'd have to go back and check a bunch of work.